Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello STAT students and welcome to the t-test video presentation. My name is Janine Allwright and I am the instructional specialist at Walden's Academic Skills Center, where I lead the statistics tutoring team. In this t-test video presentation, I will first remind you that we are now firmly engaging with the research questions about the greater population. We are stepping into the territory of inferential testing. I will review some of the concepts that we've addressed in earlier videos: research questions, hypotheses, and significance. We will then start our t-test presentation, and while there are more t-tests available than are presented in this video, we will limit ourselves to the one sample t-test, the independent samples t-test, and the paired samples t-test. And for all three tests, I will share how to set up the test, what assumptions we usually address. I will show examples for each test and discuss the interpretation of the SPS output, including how to articulate this for social change. Now let's get started. The figure on the next screen is probably looking familiar to you already, because I've shown this on every video presentation in this series. In previous videos, we've addressed the description of sample variables, and we estimated the population mean based on the sample mean, but we are now engaging with t-tests, and those lie on the right side of the screen, where we need the inferential test, inferential statistical results, to address and answer that question about the greater population. And to that end, let's review how we set up research questions again. We can have different kinds of research questions. We have descriptive research questions, comparative, relational, predictive, and there are probably more words that we could fit here. But in this week, for the t-test, we are going to focus solely on comparative research questions. And of course, you want to translate your research question into two hypotheses, because without hypotheses, we do not know what we're testing. We test because we want to answer a research question about the greater population, and we need hypotheses so that we know what we're testing. Usually, one would articulate the alternative hypothesis first, that is stating what we're expecting, and we pair that with its opposite. The null hypothesis is what we are testing in SPSS, and they act like a team. Please state both of them when you translate your research question into two hypotheses. Now, of course, a null hypothesis usually has the word no or not in it. It shows the variables IV before DV, and it gives a reference to the test. And when you state your hypothesis, make sure it's a statement and not a question, as opposed to what a research question would look like. To give you a quick example of what a research question for the independent samples t-test would look like, I have an example here on the screen. Of course, my research question has a question. It's written more like a formula, so you could enter your variables in here. I was taught to start my research questions with the phrase, to what extent? My chair taught me that when I worked on my dissertation. So to what extent is there a difference between the two levels of the independent variable for how they score on the dependent variable? The alternative hypothesis would state what I'm expecting. I'm expecting that there is a significant difference between the two levels of the independent variable for how they score on the dependent variable. And the null hypothesis would turn that around into a negative statement. Now, when we've articulated our null hypothesis, we can then evaluate it for statistical significance. And we would evaluate that against that set value for the type 1 error, the alpha level. On the left side of alpha, I find significance, and I would have to reject that negative statement, ultimately eyeing the alternative hypothesis. On the right side of alpha, I would have engaged with non-significance and I would not be able to reject the null. I would have to retain it. And after this brief refresher on research questions, hypotheses, and statistical significance, we are now ready to start our t-test presentation. In the literature, there's a variation of t-test, but we will focus here on 3 specific t-tests. There's the one sample t-test, and note the singular word sample. It is one group, and we will be working actually with the total sample on the data set to stand in for the greater population, and we will test our sample group for a specific value, for a specific test value that is set as a starting point. The independent samples t-test compares the means of 2 independent groups, and note the plural word samples here. These are mutually exclusive groups. You can only be in one of the groups. You cannot be in both. They are independent. The paired samples t-test, and again, note the plurality of the word samples, indicates that there are 2 groups that are being compared here, but they are paired, meaning it's the same group of participants, but they are measured at 2 different times. So it's one group being measured for a dependent variable at 2 different times. So the one sample t-test is illustrated here on this screen, and you can see that this is just one group of unique individuals. And as I mentioned, in our data set, we will actually use all participants in the data set. And to set that up, we would need a continuous dependent variable, a scale dependent variable. But if we're using all participants in the data set, then the independent variable is implied. We'll have to state our research question and translate those into the set of hypotheses. We need to test the value that we're testing against. And once we've generated the output in SPSS, we will describe that sample variable to see how it acts. And we will then evaluate the null hypothesis. We will assess the significance of the t-test results. If we find significance, we will interpret these results and also the effect size to assess meaningfulness. The effect size for a t-test is called Cohen's d. Of course, we will venture into the area of social change in our interpretation and certainly tell the story of the data. Now, every test comes with its own set of assumptions, and we will briefly address these here. This one sample t-test assumes that the test variable, the dependent variable, is normally distributed, that we assure that we randomly sampled from the greater population. For us, that is not something we can test. We have to accept that the researcher sampled in a random way. And also that the scores are independent. In other words, that the participants didn't talk to each other and predetermine the scores, but that it's truly independent. Again, that is an element that we have to trust that the researcher took care of that. And I will now take this presentation to SPSS, where I will create a clarifying example of this one sample t-test with a specific variable. And here is our data set. This is the existing CDC data set that I've used for other videos in this video series. And I have a nice dependent variable here that measures the mental health of the participants. It measures how many days our participants do not feel well, measured over a month. It's a scale variable and would be perfect for our one sample t-test example. Now I'm going to measure this against the number 10. I mean, I think 10 is a good number of days that one would maximally mentally not feel well. At least that is my expectation, that it will come out around 10. But let's see how these participants stand in for the greater population. And if I would have to articulate my research question now, it would sound something like, to what extent do our participants have a different number of days that they mentally do not feel well from 10? The null hypothesis would be that there would not be a difference between our participants' mental health, measured in numbers of days, and the number 10. And I could turn that around for our alternative hypothesis. So I can run this test here. I'm going to click on Analyze, Compare Means. That's where all the t-tests live because they're all compare means tests. Our one sample test here. I'm going to bring our variable over. And it's rather important to look at the bottom here because this is where you enter the test value. And in my experience, this is the most made mistake when students run one sample t-test. They forget to enter the test value. For us, that was 10. I'm going to compare the number of days in this data set to the value 10. And when I run this, the output is created here, and I now can see that the test value is mentioned. Here it's 10. If you forget to enter that, you'll get a 0 there. And that is not correct, at least not for our example. This first table shows us how this variable is acting here in this data set. 593 participants answered this question. On average, they don't feel mentally well 12.87 days a month. That's the mean. Standard deviation is 10.82. I want to encourage you to write this up. I mean, describe your sample variable because you have to assume that your reader is not aware of this variable and has not seen this variable in any setting. So you want to introduce this variable to your reader. The results of the t-test live in this table. The one sample test table relates to our greater population because it's run against the 95% confidence level with that 5% chance of making a mistake. The sig is what SPSS calls the p-value, and it comes out close to 0. Just because it shows only zeros here, that doesn't mean that you can write p equals 0, because if I double-click this number and double-click it again, a very tiny number comes up that's annotated in a mathematical way, 2.0956 times 10 to the minus 10. So it gets 11 zeros to the left side of the decimal point. It's very, very small. But we cannot write p equals 0. Our APA book in chapter 6 explains that we shall write p smaller than 0.001. That's how we address very small p-values. And if I toggle back to the PowerPoint real quick to evaluate that against the hypothesis evaluation for statistical significance, then this is the slide that we were looking at earlier. And you can now see that that would lead me to accept significance because I have to reject the null hypothesis. P is smaller than 0.001, very small. And by rejecting that null hypothesis, I will actually want to go back to my SPSS output because now I will use those the mean in comparison to the value 10 to see if our participants scored higher or lower, and indeed they scored higher, which in our case is not great because in the population the number of days is not hovering around that 10 that I was hoping for, but rather it's larger than that. It's 12.87, 2.87 days higher than what I was testing against. Now I want to show you what these tables look like in a slide that I created for this output so that you understand which values are needed. Although we do not interpret all the numbers that come up in the SPSS output, we do want to mention them because you will need them in your write-up. And here is that slide. Our tables are here. They are the exact same tables that I just showed in SPSS. As I mentioned before, the first box is the description of your sample variable. The second box is the population output. The sig is evaluated for significance. Evaluate your p-value against that set alpha level. But you also need two other values to write this up in an APA way, the T and the degrees of freedom. I'm not addressing what these exactly mean here, but you will need to write them up. It's required for APA write-ups, and I recommend that you study that in your statistics book. There are examples there on how to write up the results of a one-sample t-test, but you can also find write-up examples in your APA book. Our interpretation of the results is not complete yet. We still have not told the full story of the data. Now that we found significance, we would want to reach back to that number of days that the mental health wasn't good for our sample here, as that delivers a stand-in for the greater population. And I can now see that the mean is 12.87, which is higher, almost 3 days more than what we were hoping for. So the population has more days that they mentally do not feel well, and you want to interpret that for social change. Remember, I always say that social change matters to the stakeholders. Who wants to know and who benefits from knowing? Who wants to know that the number of days that the American population feels not well comes out higher than what we would have expected? And who benefits from knowing that information? And it's up to you to deliver a creative approach there. Now that I've found significance, I will also interpret the meaningfulness of this output. And for that, I'm going to take you to a summary of the effect sizes. Remember, we only interpret effect sizes when they have interpretive quality. For non-significant results, we do not deliver effect sizes. I'm offering guidelines here for a standard list of effect sizes. Some of those will be addressed in later videos. And of course, these are just guidelines. In the literature, they might come out differently. But for the t-test, we're focusing solely on the Cohen's d. And this comes out between 0.2 and 0.5 for moderate effects. So one could argue that anything below 0.2 is considered weak and above 0.5 is considered strong. But these are my numbers. And I want to encourage you to return to your stats book and find guidance there because you want to cite that knowledge. Some instructors here at Walden also provide their guidelines for effect sizes. Now let's return to the SPSS output because the effect size was actually calculated by SPSS, as you see here in the third table. This is a feature in version 27, and this is a really good reason to be working with version 27, because if you do not have this automatically happening for you on earlier versions, then you will have to calculate Cohen's d by hand. Now the Cohen's d comes out at 0.266. So I'm going to return to my slide, and that confirms that this is a moderate effect. And that completes the presentation for the one-sample t-test, and I'm now moving on to the independent samples t-test. And this is what an independent sample situation looks like. We now have two groups that are mutually exclusive. They operate separately, and participants in one group cannot be a member of the other group. There's that exclusive membership. And these are two samples that we're going to compare for the mean, how these participants score on that dependent variable. But let's look at how we would set up a samples t-test analysis. We would need an independent variable with two levels and a dependent variable that is continuous. Now you would be able to use an independent variable that has more than two levels, but you're just flushing out two levels to set it up in SPSS that you will then compare. Of course, we'll have to state our research question and translate that into two hypotheses, and we're going to test the null hypothesis in SPSS. When we have that output, we can then describe the variables And an important assumption comes into play with the independent samples t-test, and that's called the homogeneity of variances, also known as the Levene's test. In order to understand what exactly we have to report from the t-test results, we shall first evaluate how equal the variances are between those two groups of the sample, that independent variable. And we're testing that actually in the greater population, and I will talk about that a bit more in a moment. And we will evaluate our null hypothesis as always with the help of the sig, that p-value that SPSS produces for us. And of course, if we find significance, then we will interpret the results and the effect size, the Cohen's d, and we will tell the story of the data, including the social change aspect. Now, as I mentioned, every test has assumptions, and that is no different here for our independent samples t-test. The test variable is supposed to be normally distributed for each group of that grouping variable. Of course, we have to test the homogeneity of variances and interpret the results of the Levene's test. And we're going to trust that the researcher set up this data set with a random sample and that all scores are independent. In other words, that the members in group 1 have not squared their answers with the members in group 2. And now that we've discussed the assumptions for the independent samples t-test, we're ready to run an example in SPSS. And here is our data set. I have a different variable highlighted here. I'm actually going to work with the average alcoholic drinks per day in the past 30 days. I'm going to pair this alcohol variable with the respondent sex variable up here. It's measured in two groups. Males are 1, females are 2. You don't have to restrict yourself to an independent variable that only has two groups. You can easily use a variable that has more than two groups, but then you'd have to flush out those two groups that you want to compare by group number. For us, the groups are 1 and 2, and the research question here sounds something like, to what extent is there a difference between males and females for alcohol consumption in the past 30 days? Our alternative hypothesis states what we are expecting. There will be a difference between males and females for alcohol consumption per day in the past 30 days. And the null hypothesis will state that there will not be a difference between males and females for alcohol consumption in the past 30 days. I usually pretty up the variable names a bit when I write the research question. I think that is a requirement for scholarly writing. However you set up the research questions is up to you, but it's also up to your professor. I use the phrase "to what extent" to start my quantitative research questions, but that might be differently addressed by your professor in your classroom, so please check that. Also, I venture away from using the names in the name column as they are merely arbitrary. With our research question and hypotheses articulated, we're ready to run the tests. Click on Analyze. Independent t-test is part of the compare means group, and here it is. I'm going to bring my alcohol variable over, average alcohol drinks per day in the past 30 days, and I will grab my respondent sex variable and I'll place it in the grouping box. And I have to identify those two groups that I want to compare. Even if you only have two groups, SPSS will not do that for you. You have to always manually enter the groups that you want to compare in an independent samples t-test. Click Continue. And here are our results. Just like the interpretation for the one sample t-test, this first box, this first table, relates directly to how these variables act here on this sample data set. So the participants on our data set have drinking behavior that is a little higher for males than for females. I also have more females on this data set than males. That is not necessarily an issue for an independent samples t-test. It will handle that, but that it is something to keep in mind when you move to an advanced course or more advanced approach for statistics. Now, the interpretation of the generalization across the greater population lives in this independent samples test box. The first hurdle that we'll run into is that we have to interpret the Levene's test. The Levene's test measures whether the variances between those groups are somewhat equal enough on a 95% confidence interval. This is not related to the variances of our sample. This is related to testing the variances in the greater population. We know how the variances in the sample come out. I can take my standard deviation and multiply that number by itself. And then I have the variances, but I want to know how they act in the greater population. And that is that estimate against the 95% confidence level. Now for Levene's, and only for Levene's, do I hope that that comes out favorably, that I find some equality between those variances, because that will allow me to report the top row here. This is where equal variances are assumed. If Levene's fails me, then I can report the second row. It will modify the formulas for T and degrees of freedom behind the scenes. But in essence, it's not going to influence the sixth. Still, you have to be accurate in your reporting. Now we will return to our PowerPoint to take another look at the interpretation of the Levene's test. And here is our PowerPoint presentation. Levene's acts like a secret null hypothesis behind the scenes. It's usually not a null hypothesis that we write about. It's definitely not your null hypothesis that you're testing. It's a separate test vehicle. And it's testing whether there are differences between the variances of the levels of that independent variable. And we're hoping for Levene's sake, and only for Levene's, that we will find non-significance. We want to be on the right side of the alpha level in order to fulfill the homogeneity of variances. If we land with a smaller p-value on the left side of 0.05, then Levene's is not fulfilled and we're violating that homogeneity of variances. In our case, we had a very small Levene's, and that showed itself in our output here in SPSS. Levene's is 0.000, but we all know that it's not exactly right, so we write this up as p smaller than 0.001. But this prevents us from assuming equal variances, so we shall report the second line. And I'm going to take you back to the PowerPoint now to show you what that reporting looks like. And here is our PowerPoint again, and I have the exact tables here. And just to summarize, like I did with the one sample t-test, our first box, of course, is the sample description of the variables. And please describe these variables with some details. I usually spend about a paragraph on the description of the variables. That's when I also cite my secondary data set. The independent samples t-test box is where the population output lives. Of course, we first have to evaluate the Levene's for homogeneity of variances, and that will determine which row I will report. In this case, Levene's was not fulfilled, and I will have to evaluate significance based on that second row, and I will use the t-value and the degrees of freedom for proper APA reporting. Now our story is not fully complete. I'm going back to the output because we want to talk about the story of the data, but we also want to address the effect sizes. And in our output, we can now see that we found differences between males and females, and I know what those differences are. I can see that the males are drinking more than the females. 2.49 versus 1.75. And you're going to have to ask yourself who the stakeholders are in this social change interpretation, who wants to know about that alcohol drinking behavior, and that it's higher for males and for females, and who can benefit from knowing. Of course, your healthcare services at maybe a federal or state level might benefit from knowing that. I also think at lower levels in your society, maybe agencies that offer services for alcohol addiction, maybe at a therapy level. There's a lot of information that can be shared from this. Effect size wise, we'd have to interpret our Cohen's d like we interpreted before, 0.38. And if I compare that again to the threshold values that I set for the interpretation of the Cohen's d, that you can see here, you can see that that is a moderate effect size. And that completes the interpretation for our independent samples t-test. We have one more t-test to comment on, and that is our paired samples t-test. If you take a closer look at this picture, you can see that these are exactly the same group of people. I'm comparing this group for 2 moments in time, which means that I'm using all of the data set. The IV is implied, but I have 2 variables that are continuous at time 1 and time 2. I will have to state my research question and my hypotheses as always. And when I have the output in SPSS, I can then describe the sample variable. I can evaluate the null hypothesis by using the sig, the p-value, and comparing it against the alpha level. And if I find significance, I'm going to interpret the results and the effect size, and I will tell the story of the data. Now, it's not going to surprise you to hear that the paired samples t-test also has assumptions. The test variables are both to be normally distributed across that group. We'll trust that the researchers sampled randomly, that this random sample requirement was fulfilled and that the scores are independent. And we can now return to SPSS and run this paired samples test with an example. I'm going to close this output file first because I don't need that result anymore. And I have an interesting variable here that I've actually simulated. I didn't have a variable that was ready to run this test. I didn't have a T1 and T2. So this is simulated. I have the mental health variable that we worked with earlier for the one sample t-test, and I'm measuring that at 2 different moments before people start therapy for help to resolve their mental health issues and after they completed therapy. Let's set up the test for this. The research question, of course, for this will be that to what extent are there differences between people who report some mental health issues before and after therapy. The null hypothesis would state that I will not find differences for that mental health variable before and after therapy. And of course, the alternative hypothesis will state what I'm expecting. I'm expecting there to be differences. This is a good example to measure the effectiveness of a dependent variable. How effective is that therapy? I'm using my compare means choice again. Here's my paired samples t-test. It's also called the related samples t-test, as my 2 variables relate directly to the same group of people. So these groups are related. Variable 1 before therapy and variable 2 after therapy. And I can run this test straight up. I get more tables here. Not everything is needed for this interpretation. This first table, as always, is the sample statistics table. It describes the variables in this sample data set. I can see that the mental health measured after therapy is a touch lower. difference between 15.01 and 13.87, but is that enough to be statistically significant in the greater population? I'm not going to interpret the correlations here. That is addressed on a later video. And here are my results for the greater population. I can see here that my sig 0.058 is slightly above this threshold of 0.05. Let me bring up that slide again on how we interpret this so that you get that extra piece of practice out of it. And here is that slide again. My p-value came out greater than 0.05. That is not a matter of how much bigger it is. It's a black and white comparison for us at this moment. Either you're under 0.05 or you're over 0.05. It's not a moving vehicle. So we don't have any judgment about that, but this is clearly in the area of non-significance. And that sets us up for a little bit of an issue here, because the interpretation of non-significant results are different from the interpretation of significant results. We cannot just turn them around. And let me show you what I mean by that. I'm going to talk you through it here. Of course, we started with our research question to see if we can find differences between those groups before, or for that group before we started therapy, and then after we found therapy, we translated that question into two hypotheses. We're testing the null hypothesis. The results come out. We're going to compare that to 0.05. And when we find significance, of course, we then eye our alternative hypothesis, and we can generalize that across the greater population. But when we do not find significance and we have to hang on to our null hypothesis, that's kind of where our story stops. Because just because we didn't find it in our limited sample doesn't mean it doesn't exist. At this moment, we'd have to acknowledge that we really don't know. We'd have to try again, because there could be a sampling error at play. What if we had sampled these participants for the days that they mental health was not good, and after therapy we measured that therapy didn't work for them, but guess what, maybe they didn't make it to therapy, maybe we had an unmotivated group of people. There are many reasons that we might be sampling wrong. I'm just making it up here as I go along to give you that example, but it is something to keep in mind. When you end up with the retained null hypothesis, you cannot necessarily generalize that across the greater population. Just because you didn't find it doesn't mean it doesn't exist. So at this moment, I also have to acknowledge that I cannot interpret the effect size. I'm going to go back to SPSS. I actually have an effect size of 0.099 for Cohen's d. I cannot interpret that because it's not significant, and we do not interpret insignificant effect sizes. And I will bring that slide up for you again. This was our conclusion. An effect size only has interpretive value when p is smaller than 0.05. Do not deliver an effect size or its interpretation when you have insignificant results. And based on the fact that you were not able to reject the null hypothesis for this scenario, I want to caution you to articulate a too strong social change interpretation here. You want to mention how this came out for the participants in our data set. You did not find significance. That doesn't mean that there is no significance in the greater population. At this moment, we would have to sample again, but we cannot reach conclusions, and we'd be hesitant to interpret this for social change. And although you didn't find significance here with the paired samples t-test, and therefore your interpretation will be limited, I still want to show you what the tables look like here on a slide, so that I can share with you the important parts of this output. Of course, the paired sample statistics box is what you will use to describe your variables with the detail that they deserve. Please mention the name of the variable, how it's measured. These are scale variables. The mean, the standard deviation, and the sample size. We're going to skip the paired samples correlation box. That is not needed right now. We will venture into correlations in a later video. But the paired samples test is what delivers the population output, and that's where you want to interpret your sig. And in your write-up, of course, you will also have to mention your t and your degrees of freedom in the proper APA way. And with this last view on these tables for the paired samples t-test output, we have now come to the end of our t-test presentation.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mail.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.